Hello, everyone. So today we're going to talk about transitioning from relational databases to NoSQL. We'll look at the situation when someone would consider such a transition, but also at steps that are needed to make the transition successful. A few words about myself. My name is Grigory Morozov. I'm a staff software engineer with Diligent. Have over 15 years of experience in software engineering. Outside of work, you can find me hiking, climbing, or snowboarding outdoors. And I'm also a father of 11 months old little princess who helped me to prepare for this talk. Every developer, time to time, thinks about building his own application and probably running his own startup. So let's imagine Tom. He had a brilliant idea. He wants to build RSS reader application. He perfectly aware that there are many other RSS readers out there, but he's sure that he can build a new one that will win the market and beat all the competitors. Also, Tom is a regular attendee of our meetups. So during the past sessions, he learned a lot about relational databases, event-driven architectures, protocols, testing, machine learning, tooling, and he is ready to incorporate all this in his application. So the general architecture is pretty straightforward. It has a website that talks to some web application, built, of course, using event-driven design. And it's backed up by a relational database. And also he has a backend system that crawls feeds from the internet and populates the database. So Tom launches his application. Next day, he wakes up, looks at his metrics, and sees that he got millions of users. Sounds like success, right? Millions of users overnight. However, there is one issue, and this issue is with database. Millions of users come into the website, they generate a huge amount of read requests on his application and therefore on the database. But also, millions of users add new feeds to the system, and backend system has to constantly crawl them and populate the database as well. So the situation that database has huge amount of read and write load at the same time. Tom looks in the database metrics deeply, and he realizes that his relational database just cannot handle all this throughput. Also, pretty soon, if the amount of data written to the database will be the same, he will just run out of the disk space. So at this point, Tom realized just think that database is just an interface over hard drive, and the hard drive has physical limitations on throughput and on disk space. So the first mindset shift that Tom went through is that the data has to be distributed across multiple physical machines. You cannot store everything on one disk. So Tom started looking at the ways how he can distribute the data. And there are different known options. For example, replication. With replication, you write the same data to multiple different nodes, and then you can distribute your read load. Application can read from different machines. However, if you have problems with writes and with write throughput and with disk space on one single machine, if you replicate those writes to multiple machines instead of one problem, you have multiple problems. So replication alone doesn't help. Then there is partitioning. There's vertical and horizontal partitioning. With vertical, you split tables by columns. With horizontal, you split table by rows. And then you can put partitions on different physical machines, and this is in general called sharding. Looks like a good solution. So Tom started experimenting with it, but then he realized that there are a couple issues with this approach as well. First problem is that sharding and partitioning is not a native feature for relational databases. It was added to many of relational databases in the past few years. However, in most cases, it requires manual maintenance to make sure that your partitions do not fall apart. And Tom, he still works alone on his project. He doesn't want to spend lots of time maintaining his partitions. He wants to focus on building new features. And then another problem that he found with sharding of relational database is that it's very likely that the related data will occur on different physical nodes. For example, articles and feeds, when you join them, articles that related to the same feed may occur on different physical nodes, and then the request would have to grab the data through multiple nodes and then join them, which is very inefficient. So the situation, the summary of the situation that Tom found himself is he has high read and write load on the system. He realized that he needs to distribute the data across multiple machines, but at the same time, he wants to keep high performance of his application. It's probably one of the killing feature that he suggests to his users. And also, obviously, he doesn't want to spend much time on the maintenance. So Tom decided to try NoSQL. He never used it before, but he've heard that it's been around for over a decade now, and it was invented to solve specifically this problem: distribution, effective distribution of the data across multiple machines. Also, he read from many respected people that they highly recommend to take NoSQL solution seriously. For example, Martin Fowler, author of a few books on enterprise patterns, and also one of the authors of Agile Manifesto, also recommends to try NoSQL. So, but the first concern Tom had before trying NoSQL, I already have all these relations in my database. So will I have to get rid of them? And does it mean that NoSQL means no relations? So the first thing he found is good news. Relations are still here. They don't go. Items are still related to, between each other, no matter how we store them. But to have good relationships, you need primary keys. So Tom started reading about primary keys in NoSQL databases. And there are a few terms that he easily found. There's simple primary key, if primary key called simple if it consists only of one column, and then composite or compound primary key when it consists of more than one columns. Then there is partition and sort key. They are part of primary key. So partition key is something that you always must have in your primary key. And the partition key, sometimes it's also called hash key, is responsible for distribution data across partitions. And then sort key, or sometimes it's called clustering key, for example, in Cassandra, it is responsible for ordering of the data inside the partition. So if you have only partition key in the primary key, it will be simple primary key. If you have both partition and sort key, it will be composite primary key. Pretty straightforward. Also, some databases allow more than 2 columns in the primary key, but understanding those two were essential. Another important thing that Tom learned about partition key is that they need to be of high cardinality to guarantee that data will be evenly distributed across partitions. So Tom looks at his relational model. He has 6 tables, and each of them has primary key, which is just numeric after with incremental IDs. So those primary keys have high cardinality by default, right? So why not just to take those tables and create them in a NoSQL database, as it seems primary keys match. Nice. So he tries, and he tried different options. He tried Cassandra, MongoDB, DynamoDB, but all with the same result. He was able to create tables. However, when he started writing actual queries to request the data, he found that NoSQL database miss a few features that he used to use in relational database. There are no joins, no foreign keys, no auto increment in NoSQL, all those nice features that he used in the relational database. So instead of giving up, Tom started thinking how to use NoSQL properly. And he decided to call his friend Sarah, whom he knows works with applications that uses DynamoDB, and this application works under high load, very efficient. So he called Sarah and asked to help to understand NoSQL better. He explained his problems and challenges with NoSQL database, and Sarah obviously agreed to help. The first thing she recommended Tom that he has to change his mindset, how he approaches NoSQL. And she said that it's probably the hardest part of the transition from relational to database to NoSQL, where many people stuck and give up, because you have to basically forget everything that you learned about modeling your data in relational databases and learn how to do it in NoSQL. That's a very important mindset shift. Without it, you cannot use NoSQL efficiently. Then Sarah suggested to sit together and model Tom's database into DynamoDB. However, then she added that we will do this exercise with DynamoDB, but if you want to use any other NoSQL solution, you can apply the same principles. Of course, small details may be different between different databases, but the core principles are the same. And the first thing that Sarah suggested to start it with is to define the core entities. So in Tom's application, he defined the 6 entities that he has tables for. And Sarah suggested to create an empty table with entity chart, which will fill along the exercise and fill those columns for partition and sort key. And that's important because in NoSQL databases, in DynamoDB in particular, you can access data only using partition and sort key. You cannot access data on arbitrary attribute. Sorry, Yuri, you have a question?
No, I'm just wondering if someone else has any questions, like, because it might be.
Oh. You need to pause?
Like, I'm just wondering, I am just trying to ask. Like, we can continue if it's clear and no questions.
Okay, so Sarah suggests to start with empty table and fill it along the way. And the second most important step in the transition that Sarah defined is to define access patterns for your application. Because NoSQL databases are usually less flexible than a relational database in terms of adding new ad hoc ways to query data. In NoSQL, you need to model your data for the access patterns, how data will be accessed by the application. So Tom came up with 5 access patterns, how the data will be accessed. And Sarah said that we'll be modeling for the success patterns then. But before I start jumping into modeling for the success patterns, I want to introduce you to a couple more concepts. First of this concept is single table design. Yes, in a NoSQL database, you can store all the data in one table, and this is fine. Single table design pattern was invented for DynamoDB. However, it might be used not only for DynamoDB, maybe applied for different NoSQL solutions. It has some benefits and some downsides, but it's one of the recommended best practices by AWS for DynamoDB. And what are some benefits of it is you can pre-build materialized joins using single table design, and this allows to mitigate this lack of joins in NoSQL database. Also, if you have a single table instead of multiple tables, you spend less efforts on maintenance because you define monitoring and backups only for one table. You don't need to do it for every table. As a downside of single table design, people mention the steep learning curve because you need to, as this picture suggests, think force dimensionally. However, steep learning curve in general is not a good excuse for not using best practices and full capabilities of the tool. So this is not the most valid argument. And the next concept that Sarah wants to talk to Tom before jumping into modeling for access patterns is a bit more about partition and sort key. Even though DynamoDB, as any other database, supports scan operations, scans are not efficient, and you want to avoid them at all costs, because scan would go through all partitions, through all the physical nodes where data is stored, and therefore it's very costly. So when you access your data, you want to access with exact match on partition key, so that each query operates only with one partition. And then for sort key, you don't have to use exact match. You can use different operations like more, less, between, some range queries, prefix match, and so on. And also there are some advanced patterns when you can build, for example, composite sort key with hierarchical relationship. However, it may not be needed in this particular application. And then if we use single table design, we don't want to name our partition key column like user ID, because in single table we store all types of items, users, organizations, articles, feeds, whatever. So for this purpose, partition key columns usually has a generic name like PK, and sort key as SK. And another common practice is to put item name in the partition key value. So the value will be something like user hash and ID. So user will be the item type, hash serves it as a separator, and then an ID. With that said, we're ready to jump into modeling for our access patterns. And the first access patterns was to get user settings. So Tom in relational model had two tables, users and user settings. There's obvious one-to-one relationship between them. And there are a couple ways to model them in NoSQL. The simplest way, you can just embed settings into the user item and store all together. In this case, we potentially could use just partition key, because sort key is just a repetition of partition key. However, we will be using sort key for other access patterns, so we'll keep it here. But you may have situations where you still want to keep settings as a separate item. For example, if you have patterns where you request only user information, and settings item may probably grow large in size, and you don't want to always request it. So in this case, you can use you can store settings as a separate item using shared partition key. So in this case, we use partition key as user, and we have different sort keys for different items like settings and users. And it allows us to query them separately if we specify both user, if we specify both partition and sort key. Or we can get all items in one query by specifying only partition key. It's also handy to add a type attribute to these items. It adds small overhead on the data storage, but on the client side, when you get a list of items of different types, this attribute can be used to easily identify the item.
Gregory, I have a question about this. So, why can't you use like primary or like sort key to identify the item? Is it like a bad practice or?
It's a good question. But in this case, we have primary key shared. Sorry, partition key shared. Primary key is altogether. So partition key is shared, so we can't use it. We potentially could use combination of partition and sort key, but if we need to use two comparisons, it's already harder than check just one type. And also, yeah, also if we use, we may query the data using secondary indexes, and in this case, it will be a different combination of partition and sort key. So it's easier to have a separate attribute.
Okay, yeah. That's...
Any other questions at this point?
Hey, Grigory, I'm really curious how evolvable this structure is, because it's quite common in software engineering that we start with a very simple model. Let's say each user has a one-to-one relation with their settings. Then we evolve it over time because we realize that users would like to be able to select different settings based on languages. And so, that one-to-n relationship becomes an end-to-end relationship. How does the data model change here in the NoSQL world?
Thanks for the question. Yeah, in NoSQL, as Sarah mentioned before, it's harder to add ad hoc queries, but it's still possible. But you need to, you want to do it case by case for each access patterns. You need to look at your current structure, and you may, in some cases, add new items or new indexes or some new attributes to existing items. And yes, you will probably need to do some reshuffling, but usually it's just one-time operation. So hopefully your business requirements doesn't change every day. Okay.
We have questions like from
Evgeny.
Evgeny. Like, would you like to ask it here? I can.
Yeah.
Okay.
I just don't understand how the second entry will look like. Will it have the same settings key, sort key?
Yeah.
Or it will be different.
So if we add another user, 3 to 4, it will be a different partition key. And under this partition key, we'll have, again, different sort keys, one with settings and one with user ID. So
I get it. Thanks. Yeah.
And another question, if it's applicable to MongoDB too, yes, we will talk about this a bit at the end, but yeah, in MongoDB, it would call single collection design, so single table design. Okay, so Tom and Sarah ready to jump into modeling next access pattern, which is a bit more interesting. In Tom's relational model, he has feeds and articles with a one-to-many relationship between them. And the application needs to access latest articles by feed. So in NoSQL, we can model it in the way as shown on the slide. So again, we use shared partition key, and we store different items under this partition key. So if it's a partition key feed and sort key feed, it's information about the feed itself, and if it's feed and article, information about article. Now, in our application, we may have a page where you click on the feed and you open another page where you want to show detailed information about feed and latest articles for this feed. So with this design, you can query this table with exact match on partition key by particular feed. And then on sort key, you can request it in descending order and limit response to n+1 items. In this case, you will get information about feed and about latest articles all in one query. So it's just one request to the database to populate the whole page. And how we guarantee that articles are latest, not just random articles. Here we use for that ULID hash. It's a time-based hash string. Each new generated will be bigger in comparison with the previous one. So when we add new article for the feed, it will end up here at the end of articles list, but before the feed, because feed prefix will, in the sort order will go always after. And if we need to get only articles, we can query, for example, by partition key with feed and the sort key that is prefixed by article. Okay.
Bro, could you please repeat the name of that hash? Like
ULID.
Yeah. Okay.
Oh, I can type in the chat. There are different options, but yeah, this is one of them. And yeah, in this case, we don't need to use auto increment, for example, to generate ID. Okay, if no other questions, Tom asks how. Oh, okay. Before Tom asks, we'll look at how at this point our entity chart looks like. So we already defined the partition sort key for some of our entities, and it's handy to fill this entity chart along the way, so you can always see what combination of partition sort key you already have, because you may reuse something, or and it's sometimes hard to keep all in mind if you have many access patterns and go through them and model them. So the next access pattern is to get latest articles by author. So the previous one was to get articles by feed, but we also have authors. And in relational model, it still was one-to-many relationship with many on the article side. But Sarah came to Tom and asked him a question. How often the author name changes? You have only author name information for this in this table. How often does it change? And Tom said, well, it actually never changes. I crawl the feed, populate the database, and it never changes. Then why don't we embed author information inside the article? We don't need a separate entity for that, because it we never updated. Okay, but you said that we can query data only by partition and sort key, but we add author information just an arbitrary attribute. in the table, how we can query by author. For that, we added those two additional attributes with strange names, JSI1 PK and JSI1 SK. And you can notice that first of them contains information about author and second about article. And then we can build a secondary index on DynamoDB table. And the DynamoDB supports secondary index. Under the hood, it builds another table for you. You can access only with read requests this table, but DynamoDB manages all the data replication for you. So you can write to the main table and all the data will be replicated into index table. And then we use this new added attributes, JSI1 PK and JSI1 SK, as partition and sort key respectively. And in this case, JSI stays for global secondary index, and PK obviously partition key. And it allows us to query all articles by author. So we need to provide exact author name, and we can get all articles written by this author. And our articles, again, are sorted because ID of the articles are in order. So again, we can query, for example, them in descending order and get latest N articles, not all of them. Any questions at this point?
I'm not sure if you will have an example later, but I wonder how would you do the pagination in this case? Because you get like the N latest articles, then you want to request a second page, for example. How do you implement it?
But like you can do it in Dynamo. It's
yeah. I mean, for sure. I mean, yes, but I mean, I'm asking how would you? I mean, maybe there's an example how you would do it, because I mean, you need to use this like starts with or greater than.
It's like DynamoDB's query supports basically offset. It may be called the different name, but
like cursor, like in general.
Yeah.
Like you can get and you can filter. It's still scan because like you will need to skip like first rows, but in general, like it works.
Yeah, but it's scanned on the partition key, so we don't scan the whole table, and that's the most important part. Each query operates only with one partition.
Yeah, but also, I mean, as examples, when you request the next page using like a greater than, and then you can pass the latest, I mean, the last ID of the article that you received, and then you use greater than in your sort key query to get the next like a portion of your scan. Right?
Yeah.
Is it correct? Yeah. Okay.
Yes. It basically gives you the latest ID that was returned, and you can next query do with greater than the latest ID.
Okay, cool.
Just a question over here, Grigori. If in the case where an article does not have an author, and then there are maybe multiple articles which don't have an author, how is that situation handled?
If article, well, in DynamoDB schema is not fixed, it's flexible, so only basically you need to write only partition and sort key, and if article doesn't have an author, it will be just, there will be no such attribute in this item, and then you probably won't fill those two attributes as well because you don't have author, or it's just enough not to fill partition key for secondary index, and then this item just won't appear here. So if you don't have author, you don't want to request the article by it. Right?
But it depends on like your business logic, because for example, you can say that after unknown, like it depends like how you think about it as software engineer, what kind of requirement you have like from business.
Sure. If you want to support unknown author, you may have also have written it as unknown, and then you'll just request secondary index by partition key author unknown and get all articles with unknown author. Yeah, thanks Yuri for this addition. Okay, so this was almost straightforward. Let's look at more advanced thing. Tom says that, okay, in my relational model, I have users and I have feeds. And one user can subscribe to multiple feeds at the same time as multiple users can subscribe to the same feed. So it's natural many-to-many relationship between items. And in relational model, I created a separate table with subscriptions to hold this relationship. How do you model many-to-many relationships in NoSQL? Sarah said, well, yes, many-to-many relationships are tough in any databases. Even in relational, you had to create additional table. And it's not easier in NoSQL. However, we can focus not on the relationship itself, but on the access pattern. We have access pattern to get all feeds to which user subscribed. In this case, we can model for this access pattern, and we can add new items to our user partition. So basically, we put all feeds to which user subscribe to that partition. And this will be separate items with type subscription. Thing is, you want to put here only information about the feed that is immutable. Because if you put something mutable about the feed here, when this mutable attribute will change, you'll have to go scan the whole table, find all occurrences of this feed, and update it. It's very inefficient. So you can keep only immutable information. And it's in this case, it's okay that we duplicate the data because it never changes. And it allows us to query, in one query, get all feeds that user subscribed to. However, because it doesn't have all the information, most likely you'll have to do another query from your application to get detailed information about those feeds. So in some cases, you cannot avoid multiple requests to the database, but at the same time, each of these requests are efficient because first request, you just get feeds by a user. It's in the same partition. And to get information for multiple feeds, you can use batch request to DynamoDB to get information about each feed. Okay, but we also have
question related to indexes from Evgeny, and this question about like queries like give me articles dated last Monday, for example. How to create such kind of indexes?
Give me articles dated last Monday. Okay, so can we make it more clear? So we want to get all articles that were added from last Monday and up to today, or on exact date, because we as I said, we need to know ideally the access pattern before we start modeling. So if we know access patterns, we can model for that. If our So another option for this, if our request for articles will be based on dates, not just on order. If we go back, to articles, in sort key, we could use, for example, article and the date that it was added to the system, not necessarily the ID of the article. If you use string representation in ISO 8086 format, it will be still in the order, and you can also query based on date patterns.
Okay, thanks.
Yeah, I think we have also answers in the chat. Okay, so we were able to get feeds by users. Also, you may notice that we changed our mind, and now we're using a unique name for the user instead of identifier. It's not, it doesn't make big difference in this particular case, but in general, if you have an attribute that can uniquely identify an item, it's better to use it in your as identifier for the item instead of just generated ID, because some generated ID, it doesn't hold any value about this item. It's used only as identifier. But if we can use an attribute which is unique as identifier, and we, for example, have some access patterns that using this attribute, in this case, we can save. It can save us from creating additional index in the future. So, using existing attribute of that item usually is more beneficial than generating a new ID. Okay, so we were able to get feeds by users, but Tom also needs to get users by feed. How we can do that? And one way to do that, we can use global secondary index again. So for those subscription items that we added in the previous example, we can add global secondary index PK and SK attributes. And you may notice that for partition key in the index, we use sort key from the main table, and for sort key, we use partition key. This is, in general, very powerful pattern when we flip partition and sort key in the index. And if we look at these items in the index table, we'll see that now we can get users by feed. Again, if we need to get detailed information about each user, we would have to make another query from the application, but this is sometimes unavoidable. But again, if some attributes of the users are immutable, we could put them in the subscription item as well. Okay, so seems we covered all 5 access patterns that Tom asked us for. And our entity chart at the end may look something like that. We have partition sort key for each item, and also global secondary index is used for 2 different access patterns that are not covered by the main table. So from what we had in the beginning, 6 tables in relational model, we got a single table. It may not look that pretty as you would have it if you display just relational table, But it works, and it works very efficient because all the information related to a particular item is stored in the same partition. So we have partition for the user, and we have all
Grigori,
items that.
I'm sorry for interrupting. We have a question in chat about GCI1 and GCI1 PK.
Okay, so GSI1 PK is just global secondary index 1 because DynamoDB supports more than one. You can create multiple secondary indexes. So 1 is just to identify it. If you need more, you can. The name can be any. It doesn't have to be this, but it's a common practice to use some generic names that are clear to identify it from other attributes. So global secondary index 1 is its name of the index in general, and GSI1 PK is the attribute that we use as partition key for this index. And then global GSI1 SK is attributes that we use for a secondary key for this index. Source key, sorry, for this index. Is it possible to use these techniques using only DynamoDB key? Yes. When you create DynamoDB table, you basically define only attributes that for partition key, sort key, and if you have secondary index attributes that will be used as partition key and sort key for secondary indexes. All other attributes are not defined during the creation of the table. So when you write your data, you can write whatever you want. You can use JavaScript SDK for that too. So back to the final view of the table. Yes, again, the key point here is that all items related, for example, to the feed are stored in the same partition. So if we need to query them, we don't go over different partitions. And the same is true for global secondary index table. All items related to this feed are in the same partition. So what benefits Tom get from this transition? He got a highly scalable solution. It can scale to basically infinite amount of writes and reads. He got predictable performance because each query works only with one partition, because you always query using partition key. Performance of each query is efficient, and also it does not depend on the size of the table. You can store terabytes of data in the same table, but it won't affect the performance of each request. And also, since NoSQL doesn't support joins, and the join by itself very compute intensive operation, we don't spend much money on CPU, and because of for the same reason, it's environment friendly because we don't hit air with this useless CPU cycles. As Sarah mentioned at the beginning of the exercise, Tom can apply similar approach to basically any NoSQL database. There are quite a lot of them out there. So Tom can choose whatever he feels suits better for his task, for this one or for next project. And to encourage him more, Sarah showed some statistics that many really huge companies successfully transitioned from relational databases to NoSQL. This is just a few examples, and it proves that this transition can be done for the company of any scale. Would it be just a single indie hacker or huge corporations like Netflix or Amazon? So some key takeaways that Tom got from it. Transition to NoSQL requires mindset shift. You cannot apply a relational mindset when you build and model data for NoSQL. You have to learn best practices and patterns for particular database you choose. Of course, basic core principles applies to most of them, but there are always nuances. Each database has documentation on how to model data to efficiently use it. And of course, NoSQL is not a silver bullet. You need to understand trade-offs and limitations of it to make informed decisions. If you want to learn more about transitioning from relational databases to NoSQL and about single table design, I would recommend those two authors. Rick Holohan is author of single table design. He worked for many years in AWS, and now he's back to MongoDB, which makes you can be sure that MongoDB also supports single table design. And Alex Debris is author of DynamDB book and also author of many articles and videos about DynamDB. So you can find lots of materials from those people. And again, for any database, they usually a good documentation on how to model data for this particular database to use it efficiently.
Awesome. Thank you so much, everyone, for joining. And thank you, Grigory, for this amazing presentation. Also, I would like to announce our next event is going to be on March 1st. We are going to talk about like scaling up Jupyter notebooks. We already created an event, like you can RSVP for it on meetups.com. Also, in April, on April 5th, we are going to have another talk, and it's going to be some magic, the same magic as we had today with single table design. It's going to be magic how to not write code at all, and it will be about no code solution, but no code, not when you just configure in UI. No code. It's about like serviceful solutions that exist today, and for example, like how to connect different services and use existing infrastructures that are done by other companies. It's going to be April 5th. See announcement later. And we're still working just to bring reInvent speakers exclusively for this meetup group. See you in the future. Thank you, everyone. Bye.